Yes.
Good evening, everyone. My name is Ankesh. On behalf of Cambridge University Press and Assessment, I welcome you all to the third session of Maths Masterclass, Investigation in Mathematics. Due to the limited seat in Zoom, we are live streaming this particular session on our Facebook channel as well. In case you face any trouble or you know any of your colleagues who are unable to join us on Zoom, please share the social channel link with them so that they can have a glitch-free experience. The links are posted in the chat and that chat is currently freezed. I request you all to kindly use the chat options for all your interaction. There is also a question and answer tab available within the platform for you to post your questions. So those of you who are joining us for the third session, who already know our trainer for today, Ms. Monica Kocher. For those of you who are joining us for the first time, let me take the privilege to introduce our trainer for today, Ms. Monica Kocher. Ms. Monica Kocher is a maths magician. She has given numbers a heart and abstract concept a ground to stand upon. She has taken the sting out of mathematics learning. She is like a doctor who cures maths phobia. Her approaches to mathematics is not only interesting, but more human. She believes maths is not about acquiring the skills of playing with numbers, but it's a journey that makes you a more rounded person. As per her, when maths combined with art and poetry becomes a red-blooded poem, a splash of color, a game that is played on the sports ground. She has applied these concepts successfully in a long and colorful teaching career spanning CBSE, ICSE, and IGCSE schools. She has also successfully worked with leading clients for over a decade as a solopreneur, winning titles such as LinkedIn Education Voice of the Year and Global Influencer in Education. Please join me in welcoming Ms. Monica Kocher. Over to you, ma'am.
Thank you, Ankesh. Thank you, Cambridge team. And thank you to all the teachers who are joining, teachers and others joining from various virtual networks across India and outside. This Mathematics Masterclass series, today's session is Investigations in Math. So please be ready because there will be questions, because I don't think we can have a session on investigations and not investigate into our own thinking. And as shared before, for any mastery, and especially for math mastery, what we believe in is we need two steps: bring children to maths and take maths to children. Our previous sessions, which were on integrating art, integrating games, were more like bring children to maths. Today's session is more leaning towards take maths to children, because this is completely and totally an area where we get children to think mathematically, as NCF 2005 claim. So, as always, the presentation will go taking questions like what, when, why, how, and that is how we will proceed. So drawing from the latest NCF, which says as one of its learning outcomes, students should perform simple investigations related to specific questions independently or in groups. And I have highlighted this independently or in groups because the experience and the learning that you get when you work independently is different from when you work in groups. And both are important. As I used to tell my students when I was teaching, that when we grow up in the grown-up world, we need to learn how to work in groups, and we need to learn how to work independently by ourselves. And investigations gives a space for both. So perhaps the simpler ones can be done independently, the harder ones can be done in groups, but perhaps the kids who are absolute geniuses can do even the tougher ones independently. So play around with these and see what works and when. So before we get into investigations, I think we could have a bit of a pause and see What is the difference between problem solving exercise and investigations? So on the screen here, there are 3 questions based on this graph, which has 1 point is plotted as 2,1. The first question is find the equation of the line through the origin and the given point. Origin is here, given point is here. Second question is find the equations of lines through 2,1. Third is investigate equations of lines intersecting at a common point. Now, my question to you is, and Ankesh will help read out some of the answers. Which of these 3 do you think is problem solving exercise and investigation? You can just write 1, 2, 3. Like, do you think 1 is an investigation, a problem or exercise? And what do you think of 2, 3? So we'll just wait, and Ankesh, I'll need your help here to just read out maybe few answers, 4 to 5. And
Sure.
then I'll give the answers. Thank you.
1, 3, 2.
So which one is which? You'll have to specify. Are you saying 1 is exercise, or is 1 a problem solving, or 1 is an investigation? What about 2? What is 2? What is 3?
3 is investigation, 1 is problem solving. Problem solving 1 and 2, 3 is investigation.
I think this is already giving the answer. Investigate
Yes.
equations of lines. So 3 is investigation. 1 is an exercise. It's a routine exercise question. Simply find equation of the line through a point, given, and origin. So this is what we call as a convergent question. You have a question and you have a single answer coming to it. Second is classified by the teacher who gave this as problem solving, because when we say find equations of lines through 2,1, we are not specifying how many. We are also not saying which ones should they be parallel to x-axis, y-axis. Answers can be different here. It's an open-ended question. And hence, this is more like a problem-solving method of teaching maths. The third, obviously, is investigation. Not even information is given. Simply, what happens to equations of lines that intersect at a common point? And that common point can be 2,1, but that common point can be anything. So here is a bit of a difference. When we say an exercise problem, it's a convergent problem. Everybody gets the same answer. When we say a problem solving situation in math, we would say a little bit information is given, but answers can differ. Third is even the information is taken away. The only thing which is given is a very generic thing that lines are intersecting at a common point, and then investigate what happens. So we are not even saying they will pass through a point, not pass through a point, simply what happens. So investigation is very, very divergent and open-ended. So here's another task for you, and you can again write answers in the chat box. This is an investigation. Amy picks 3 of these cards and gets a total of 9. Which 3 cards might Amy have picked? And we'll need Ankesh to again tell us the answers which are coming. Thank you.
2, 3, and 4, 1, 2, and 6. 3, 5, 1, 1, 3, 5. Maximum 1, 2 is the common answer, ma'am. 1, 3, 5, 6.
Got it. Got it. So basically, everybody is getting a different answer. It's a very simple investigation for the primary year kids. So a suggestion is whenever you give an investigation and the answer comes, dig deeper. So I'm adding one more question to it. Now you'll have to tell me yes or no. Can I choose 8 as one of the cards here? Remember, the total should be 9 and I'm picking 3 cards. So can I pick 8 as a card here? Yes or no, Ankesh?
Maximum answer is no.
Yeah, absolutely. Because 8, I add 1, I have 9. I don't have a third number. Can I choose 7 as one of the cards?
Yes is the answer. No, no. So it's a mixed response, ma'am. Some answering yes, some
we cannot. Yeah, because each card is here only once. If I have 7 to make 9, I'm going to take 2, 7 plus 2. And then where's the third card? If I take 7 plus 1, 8, Where's my third card? So I can't pick 7, but I'm really happy that some of you answered yes, some no. That shows that this is a question which is a bit tricky. Final question. Can I take 1 and 3 as 2 of the cards? Think carefully before you say yes or no. Can I take 1 and 3 as 2 of the cards?
Yes is the response that I'm getting, ma'am.
Yes, absolutely. 1 plus 3 is 4. 4 plus 5 is 9. And therefore, I can take 1 and 3 as 2 of the cards. Now, please note, as an investigation, the whole idea here is to get kids to think and think in different directions. That's what it means by divergent. Investigation is divergent because it's like you are on a road and you have so many pathways in front of you. Which one would you take? That's what investigation is. So drawing from simple definitions, mathematical investigations refer to sustained exploration. So basically, you're exploring and you're sustaining your stamina for it. You're not saying, I don't know the answer, I give up. Or ma'am or sir, you tell me the answer. You're exploring. It distinguishes from problem solving because it is open-ended. What I meant by when I said divergent is overlapping with open-ended. It's an open-ended. There are multiple solutions possible, multiple ways of solving is possible. Problem solving is convergent, very definite goal. Here's the question, here's the answer. Mathematical investigation is explore and see where do you get. Investigations are also different from word problems because there could be so many ways of working them out. You could also have kids coming back and saying it's not possible to solve it. So it's again exploring, it's using trial and error method. That is what a mathematical investigation is all about. There can be one answer, there could be several. Multiple investigations are available on the internet. There is no dearth of them, but do remember, pick one which is giving a chance for the kids to have exercise their divergent thinking. That's the objective here. Why should we use investigations? Let's hear it from a teacher.
The beginning of a series of lessons to try to scaffold the language. Hands up and tell me what this word is. Everybody whisper it to me. Predict. I thought you'd know that. And what does predict mean? So what I did was actually a non-math thing, and I started reading them a story, and it was about predicting. So because I think they've had a lot of experience with reading stories and making predictions and hearing that word predict, that would be a link between that and their maths. Who can predict the story? Sophie?
They might eat all the fish and there'll be no more left.
You think they'll run out of fish? You know what, that's a great prediction. I like that answer. I wanted children to be thinking about prediction, and I wanted them to use some data that they had collected to make predictions that would help them in the next lot of data that they were collecting. So it was a very simple kind of collection of data where they were asked to predict how many blocks or how many objects that they could pick up in their hand. So they had to make the prediction first and then actually pick that up. And how many can you pick up from here? Let's have Lily. How many do you think?
11.
You come and see. See, who thinks Lily could be right?
Can we count them?
If we need to, that's a good idea. 36. Okay, let's just stop there. How many did you say, Lily? 11. And how many did you have?
6.
About 36. So you had a lot more. Then what I tried to do was get them to think about, well, if you've picked up these unifix cubes and you've got your prediction, maybe the actual number that they picked up was more or less than what their prediction was. But then I wanted them to think about that so that when they went to pick up some other items that might have been a different size or a different shape, that they might be able to make determinations as to how those variables would influence their prediction and influence how many they could actually pick up. Fantastic. What about you, Sophie? Did you make a prediction?
36.
Was that your prediction? And what are you doing now? Counting them to test. So they have to be able to develop methods that communicate their mathematical thinking through that literacy of maths. And some of the children thought that it would be a good idea to write that information down. So they can use what I call invented recording. I don't necessarily ask them to use standard recording. I usually don't teach them standard recording. So they write down what they've done as a record for their memory so that they can share it.
I got 97.
Oh my goodness, that's a big one. What were you picking up?
Those marbles.
And we did have some conversations about the size of the objects and how that would impact on the number of objects that they could hold in their hand. Oh, the marbles. And why do you think you could pick? You picked up more than what your prediction was?
Because they were littler and I had a big hand.
Oh, you've got the big hand. Some of the children actually.
So here I want to stop and I want to ask the teachers. I'm very curious to hear from maybe Ankesh. We'll need your help here. 3 to 4 teachers. What is any discovery that you have made? What is this teacher doing through the investigation? I mean, anything that you picked up from this video? Like, for example, when I looked at this video, this is the 3rd or 4th time I'm looking, and I found that at every step, she was getting the kids to talk their thinking aloud. And though they are very small children, but she was getting them to talk. What is it that you noticed, something striking in this video? Ankesh, thanks. We'll meet you.
The response is estimation, probability. She was trying to know the concept, investigation, new vocabularies, guessing, prediction.
New vocabulary, exactly. Yeah. So she was getting them to speak at every step. At no step, she was giving the answer, and the kids were exploring throughout. Anything else, Ankesh?
Mathematical operations alone, reflection of students in learning, trying to understand the level of understanding, exposure, divergent thinking, collaboration, cognitive development.
Great, great, great. I think it's nice again to see that
It's the beginning of a series.
Very divergent responses are coming. So I guess the whole objective of investigations as a session is achieved here. So this was a bit about what of investigations. One was difference between investigations and normal problems. Normal problems that we see in books are convergent, they are closed-ended. Investigations are not only open-ended in the way that the answer can be different, like all the kids with this Australian teacher in her classroom, the method that the kids use can also be different. So that is what an investigation is. Now, how do we run an investigation in the class? Doing investigations requires a very clear mindset shift. One of the biggest mindset shifts that kids need is a question can have different types of answers. It's possible that 30 kids in my class get 30 different answers and all of us are correct. A question can be solved by multiple methods. So the mindset shift in the students, they need 4 attributes here. One is growth mindset, which is, it's okay if I fail. It's okay if my answer is incorrect. Let me try again. Just because I got it incorrect doesn't mean that I'm a bad student. The other is problem solving. You know, that excitement that, okay, I have a problem and I'd like to solve it. Detective mindset, like Sherlock Holmes, where you have a problem and you really want to get into it through trial and error, using standard methods, non-standard methods, but you want to come to an answer. And finally, for group work, collaboration would be most important. Very curious to know from teachers again, which of these 4 do you think would be most important in any human mind who would be good at solving investigations? And we'll bother Ankesh again now to give us few replies here. Which of these do you think is the most important? Growth mindset, problem solving, being a detective, or collaboration?
Ma'am, problem solving, detective, somebody says all 4 are important. Detective mindset and collaboration is important. All is a prominent response, and growth mindset and problem solving is a prominent response that I'm getting on chat.
Yeah, It's very true. All four are important. And if the kids are working alone, then growth mindset, problem solving, and detective. If you're not worried about failure, growth mindset is that okay, I got it wrong, let me try again, let me try again, let me try again. If you are worried, if you think that if I get a wrong answer, there's something wrong with me, you won't be able to go very far with investigations. There has to be an excitement for problem solving and a bit of a detective. So you can even excite the kids in the class by saying, okay, let's all of us be Sherlock Holmes today, and we are a detective for the day. It also requires a mindset shift among the teachers. And here, Ankesh, if you can explain, there is an online poll which we are going to run here, where we would expect you to give us some responses.
Okay, so participants, the online poll chat link is posted on the chat. The chat is currently freezed so that you can easily click on the link and share your response. For those of you who are those of you who are attending from Facebook can scan the barcode and submit your response.
So there are two ways: scan the barcode, or here is a link. This link can be clicked and all the responses will come here. There are only 4 questions with answers as always, sometimes, never, and the responses will come over here for the group which is here. Let's just run it for maybe 2 minutes. Ankesh, what do you say?
Sure, ma'am.
And then we'll stop accepting responses and see what everybody gets. So this is what is expected. Please let me know when to stop. We have only 9 responses, 10.
Okay, some people are asking to reshare the link. The link is already there in the chat box. Just click on the chat box and you will have the link. The chat is currently freeze so that there's less of a distraction there, and
Yeah.
you're
You can also
easily
type the link.
Yeah.
bit.ly/mathspoll. I'll make it bigger. So if you can just type this, there's a very small link and you can go directly to this link and do it. It will bring you here and there are 4 questions. Let's pause at 50.
Okay, I am getting response. It's not opening. Please copy and paste the link on the browser directly. The link.
Yeah, the whole link, http:// we tested it before the presentation and
yes,
it's working if you try all of them.
Let me open the chat as well to see if others are able to post. Can the participant post yes or no in the chat in case they are able to? It's working. Perfect.
Okay, shall we pause?
Yes, we can.
Okay, so now not accepting responses. So we are getting, sometimes we present unfamiliar investigations, sometimes encourage students to record their own procedures. Always, that's amazing. Posing open-ended problems is sometimes. So I think this is the part which maybe can be looked at, and quite a few people say always, but nobody is saying never, which is really fantastic. You encourage the students to work in small cooperative groups. That's also always and sometimes. So this is really fantastic that the group is doing this. The poll is closed in case anybody is having issues, so you won't be able to do. So this is something which shows that at least the group which has responded is doing some work in investigations in the class. Otherwise, what we would say is teacher qualities for an investigation-based class is, the first part is where most of you who answered said unfamiliar investigations are sometimes. Bring unfamiliar investigations where, or maybe a question which you haven't taught how to solve, and then just leave the kids to solve them. If you feel maybe would they be able to do it, not do it, let them be in groups of 4, and just give them an unfamiliar situation. We think they won't be able to do it, but let's be a detective ourselves and let's see what happens if I give a completely unfamiliar investigation to kids. Will they be able to do it? Will they not be able to do it? Let me do an investigation on investigation. Encourage students to record their procedures, like the teacher, Australian teacher, was saying. She was asking the kids, how did you record? What did you do? So some of them may record it on paper, some of them may draw, some of them may make an audio. Give open-ended problems. Enough problems are available on internet. If you just type investigations in mathematics, you will get problems. One of the best website is NRICH, NRICH, and you get problems from there. And finally, encourage the kids to work in small groups. There will always be kids in some classes, or I think almost all the classes, there will always be kids who are not that savvy with math. So if they work in groups, the advantage is that the kids who are not good in maths, maybe they are good in language, maybe they are good in leadership skills, and they would be able to contribute to the group as well as learn from their peers. So these are the 4 qualities that I think should be there in a teacher. Have I missed out something? And Ankesh, if anybody is responding, if you can just give us 2-3 great responses. Do you think there's something more that a teacher should have to run an investigation-based class? My points are: present unfamiliar investigations, encourage them to record their own procedures, give open-ended problems, and encourage to work in small groups. Anything else that you feel should be here?
Ma'am, the responses are reflection, differentiation, be more curious, not to run behind the curriculum completion, sorry. Differentiation and question, patience, clear instruction, planning.
Yeah, great. Not be so worried. I think that's the most important part, is don't be so worried that my curriculum will not finish, my syllabus will not finish. One class where kids are doing investigation and at the end of it, they present their responses will create so much of enthusiasm that the next 2-3 classes, it's going to spill over and your syllabus might actually run faster, as some of us have discovered. But even if it doesn't, let's, as a teacher, be an investigator ourselves and let me see what happens, and develop enough of a growth mindset to say, okay, so it may not work, so I may fail, but that's okay. Let me at least try. So this is the teacher qualities. The other thing that the teachers can do is to bring to the children multiple problem solving techniques. So here's another question for you. Just watch the various types of problem solving techniques, and just type in the chat box, how many different problem solving techniques have you taught the children? Children, when they come to problem solving, they also need to be taught how to solve problems. So there's trial and error, there's draw, visual, there's organize data in a table or a graph, there's look for patterns, model it where you show how to do it, work backwards, imagine what the answer is, or know the answer and then go backwards, and circle what's important. These are just some of them. In general, how many different problem solving techniques do you use in the class to teach the kids? You can just write a number in the chat box, 2, 3, 4, 11, 13, 15. And let's see what the group responses. Ankesh?
3, 5 approx. Trial and error approx 4, 5, 6, trial and error approximately 4.
Got it. 4 is not enough, especially if you're teaching kids, even if you're teaching kids of K8. Try and stretch, look for problem solving techniques. Just Google it, problem solving techniques in math or active learning in math class. There are 7 of them present over here, which can be used pretty much for all classes. Try these, and again, be like a detective and see, okay, I'm trying this today for 15 minutes. Let me see how the response is. Based on the response, I'll decide whether to continue with it or not. So that is something we would expect teachers, is to keep learning more and more problem solving techniques and keep taking it to kids so that they can learn to choose. Thanks, Ankesh. Then we come to implementation. Now, implementation generally for a problem solving class or investigation class has a 3-act task. It's like theater with 3 acts. First is trigger their thinking, pose a problem. First time you're doing it, probably kids will be very charged, very excited. They will ask questions, they will read. If you have access to resources, maybe give them a printout with each group. If the kids have laptops in your school, email it to them so that they can all see, or project it on the board. If these resources are not available, it can be written on the board, or you can write it on a paper and just stick it on the wall, or any other way, depending on the resources. The first step is simply pose the problem and give it to the kids and say, this is what we are going to do today. When the class has read, has asked all their 10,000 questions that kids usually have, once they are done with that, or once your time limit is done, that you have 3 minutes to understand what is the problem, put them into small groups or individually, that's up to you, but in small group discussion. Always give them time and have a timekeeper in each group, otherwise your class will never end. Maybe tell them you have 10 minutes to crack it and find a solution. And then finally, whole group discussion where a representative from each group comes back and gives the solution to others and everybody comments. You may have someone coming with incorrect answer. You may have someone coming with correct. You may have someone coming back and saying, couldn't solve it. That's perfectly okay. But these are the 3 steps, and always have very clear time for each. Let me say, for a middle school class, I may say 3 minutes for the first act, maybe 30 seconds for you to get into groups, and 10 minutes for the cracking of the problem, and finally 10 minutes. And so it should ideally end in one lesson. And maybe the best solutions can go up on the classroom board for the kids to look at and be excited. I tried this once long back in a class of 30, and I found for the problem that I posed, by the end of the lesson, there were 16 different ways of solving that problem. And there was one student who solved it so elegantly, as they say in math, which minimum steps were used to solve it, that the whole class just got up and clapped. So, question for you, one whole class for one problem. Do you think that was a good math class or a bad math class, and why do you think it was so? So please comment, and maybe 1 or 2 answers, Ankesh, we can see what the group feels.
No differentiation is important. Depends on the depth of questions.
It was a deep question. It was an investigation, but the whole class did only one problem in 30 minutes.
It gives a different approach. Please could you go? Good, as the concept was inculcated. Good because it's easy to achieve the objective. Different answer. Got different types of methods to solve. So really good class. Competitive mind. It also depends on the concept. Focus. Yes, it's good as you get multiple answers. If kids were interested in listening to each other strategies, then it could be good.
Yeah, they were. That's a very good thing to say. Thank you. Thank you, Ankesh. So overall, all in all, great class because the kids were so energized that for the next whole week, I didn't have to do anything to motivate them to learn math because they came so energized. They also discovered when other students gave their responses who were the good kids in math in class. And so there was a very different kind of an environment as they learned who they can go to for buddy learning. They discovered new approaches with their own friends that, okay, she may not be that great in math, but she was a great leader in this group. He may not be that great in math, but he really helped us keep the time. So there was a very different kind of bonding in the class. And yes, discovery that a problem can be solved using 16 methods. It ended with kids doing this normally in their exercises. For every problem they would solve and then they would try and see, can I solve it in some other way? And then their math developed. So this was the response. This was like the impact of a lesson like this in one of the classes. Of course, it would be different everywhere. So bring technology into your classes for investigation, and I will show you how. Desmos is one of the best websites to go to. And I just picked up this activity more to show technology. In case you're not using, Desmos is used, it's free. Teachers use it a lot, teachersdesmos.com. A lot of activities are already created, but you can also create your own. And then if you join them, sign in, it's all free. You can assign these to the kids. So what this teacher is doing is, here is your investigation. This little guy hopped right into your yard. You need to make a pen to hold him until you can find his owners. You want the pen to be big enough for him to move around. In your garage, you find a 72-foot roll of fencing. It's a very common problem. Those of you who have taught middle school would know perimeter and area. This is used a lot. What do you think will be the possible answers here? You can tell Ankesh and I'll just type them here. Maybe 2 to 3. What kind of rectangles can we get with 72-foot roll of fencing? What are the possible dimensions? You just have to give the length and width. Any answers, Ankesh?
9 into 8.
Okay, 9 and 8. Then
12 and 6. Factors of 72. 12
so
and
you
6.
need to give us the factors. So 72.
12 into 6. It has to be a 24 into 12, 24 into 3.
24 into 12. Will that give us?
20
that
into
give us?
16. 18 into 4. 12
Okay.
into 6.
Thanks. We stop here. So what the kids would normally do is they can give the answers, upload an audio, or they can write it and they just click submit. And the submit, the answer goes. Then the activity, let's see actually what the responses for this are.
So let's take a moment and think about what the dimensions of the pen could be. We are given a couple of parameters to work with. We know that we have 72 feet of fencing. And we know that we're building a rectangular pen, so that's going to be a 4-sided figure with each of the 2 sides being equal to one another. So essentially, what we are really working with are 2 sides of a rectangle that are going to have to add up to be 36 inches. Right? So if we can think of 2 things that add up to be 36, we could really start to get our rectangles there. So 2 things that I know add up to be 36 is 12 and 24. Okay, 12 plus 24 is 36, and then we'd add another 12, which would be 48, and then we'd add another 24, so we'd be at 72. Oh, this would be feet. Okay, so that would take up all 72 feet of our fencing. Okay, so that's one possible dimension or one possible setup of our pen. And then we could have something like, let's say 36 is divided by 2. And 36 divided by 2 would be 18. So we could have 18 feet by 18 feet. Okay, essentially making a square, but a square is still a rectangle. Okay, so we could have that. We could also have something like a super long pen. So we could do something like this, where we have a 6 and a 30 here. Okay, and then we could have another, this side would be 30 over here and the side would be 6 over here. So that would even it out. And then we could also have.
So she goes on, and we can see some of you, the answers were incorrect because actually 72 is a perimeter, not area. So what she is doing is half of it would be 36. So I just need to get 2 sets of 36. She explains. She asks the kids to get the area. And then finally, that's the various areas that she gives. So I would urge you to explore Desmos as a space where you can give the investigations. Again, curious to know, are there teachers who use it? You can just type yes or no, and Ankesh can tell us how many yeses come in the first 10 answers. This is the source, teachers.desmos.com.
Yes, is the answer.
How many of them say yes out of 10? First 10?
First 10. 8 said yes, 2 no's.
Wonderful, wonderful. So please explore existing activities, use them, assign them to the kids. Technology can help a lot of reduction in the amount of talking a teacher needs to do, because technology comes as a support and kids also enjoy the tech-based investigations. So as we saw, reading this, a lot of the teachers assume 72 is area, and the answers were coming to that. That's what I meant by the first act of the 3 act. First act would be for the kids to read thoroughly, understand, ask all their questions, and then move to solve it. So here is a very interesting video where a group of teachers, after they experimented with investigations, what they discovered. But before I show this to you, are there any questions? We've been here for about 40 minutes. Ankesh, if there are any questions which we can take in the middle, it's okay. We can pause because we have time.
Ma'am, I'm keeping a tab on the chat. No questions yet. Mainly interaction that we are getting in the chat box and the question and answer tab.
Okay. So teachers, any questions, please note them down while we just sit back and watch this video.
I would say before I started doing investigations in my classroom, it was more, I think, teacher-led and teaching a skill. The kids went off and, would master it, and we would move on.
It was a very digital classroom where I would teach a lesson and then the students would go online and they would work on 10 marks, and it was all digital.
So our students are extremely hands-on with the math program. They're asking each other those how and why questions. They're manipulating things. They're discovering things. It's just a different atmosphere in the classroom where the kids are excited about their problems and how to solve them.
The discussion is a big piece. That's what's changed, I think, drastically in our room, and the excitement for math. When we say, or when we let them know that it's, it's time for math, the kids are much more excited.
My classroom has become a lot more collaborative. There is a lot more math conversation. There's a lot more of students excited to share how they solved a problem, and another student jumping in and saying, I did it a different way.
Rather than the teacher posing the question that this is what we're going to learn today, the student ends up through exploration finding out the answer to the question that's posed.
They're in the driver's seat they're definitely driving the instruction, guiding me on where we need to go next.
It's so amazing to see what they come up with before I can even think that they're ready for that concept. When we throw out a question, or when they have a question, they explore it through manipulatives and they come up with solutions, and then they build on each other.
Students realize that there's more than one way to solve a problem. So they're taking strategies that they've learned previously and applying them.
They are thinking so deeply about the process. They're not just reading a problem and solving it. They're really thinking about why they're choosing a certain strategy and how they're doing it.
I think they're gaining a better sense of number, as they work through their problem and they share their strategies, and they're becoming exposed to different strategies, that they're getting a better understanding of how numbers work.
And there's also excitement with them when they've only known one strategy and it doesn't work for them, and now they've learned other strategies that do, that they're now able to solve a problem and be successful.
Changing math programs was appropriate for elementary school children because they need to know the math sense behind it. And when you're studying and you're memorizing, there's that opportunity to forget.
And their confidence level has definitely, skyrocketed, and, they're proud of themselves that they're able to either write or talk about how they came to their solution.
We've had different programs for different grade levels. 4th and 5th grade would use one program, the primary grades would use another. So with investigations being kindergarten through 5th grade, we are developing consistency with understanding math.
The students are given a lot of opportunity in the classroom to have a math workshop time, where we call them math stations. But within those stations, sometimes it could be individual work, it could be partner, group work, and it really just gives them the opportunity to enhance some of their skills or strategies that they've been working on.
I see that they're more willing to help each other and say, like, oh, I use this strategy. Sometimes, during a quiz or a test, it's almost difficult to get them to stop collaborating because they're so used to that now.
Investigations really is collaboration.
So, question for you.
I would say before.
What is the one new idea that you learned from this conversation? So we can pause and you can share that in the chat box, and Ankesh, you can help us in. What is the one new idea? And if anyone feels, if teachers feel, we can run this again, or you can just check it out on YouTube, Edison School Investigations. But what is it that you picked up from here?
The responses are analysis, collaborative learning, investigation-based collaboration, peer learning, investigation and collaboration, different creative ideas, group thinking, think, pair, share, exploring, discussion, peer learning. I learned more about importance of collaboration. So collaboration, patience. That's a unique answer.
Yeah. Anything? Thanks, Ankesh.
Yeah.
Anyone felt like maybe this may not work? The teachers were talking about doing investigation-based classes from kindergarten to 5. Did anyone feel like maybe it won't work? Any responses there?
It will work 100%.
Okay,
Sharing
great.
and learning. It works well. So that's the response. It will take time, but it works. It surely does.
Okay, great. I felt this was a fantastic conversation among teachers, and would urge you to try and reflect. Try and then reflect and then modify. As one of my managers used to say, act, reflect, modify. That's like a detective way that let's try it out and then let's reflect what worked, but didn't work, and then modify. And in each presentation, I give a gift, a resource. So here's Ankesh, you can give that in the chat box, and for Facebook team in the comments. It's just a resource which has a fantastic investigation which can be used by any teacher in K8 with a little bit modification. It's a very nice website by a teacher who has given this. You can try it, have a look, try it out in the class. So the Presentation from my side is done, but we wanted to keep a good time in the end for questions, thoughts, comments, and filling up the feedback form. So any questions on investigations, any questions on any topic, any questions, or anyone would like to share that I tried this investigation and this was really good. This is like an open house for the time that till Ankesh tells us to stop.
Okay, ma'am, there's one question by Poonam Saxena.
Mhm.
Each investigation should be one with a purpose and objective. What different types of domains or levels of investigation we can incorporate for a class with less exposure to promote critical thinking? Also, please enlighten on investigation with integration of other subjects.
Okay, that's a really great question. So two questions are here. The first one is which domains. So if a class doesn't have any exposure, then it might be better not to use an investigation which has a huge story around it. Maybe a simple one, something like, what do you think happens when we take a point and the lines pass through it? Or what do you think happens? Maybe give them an object and say, what will happen if this object is turned around in this way or that way? Or how can we find volume of this particular object? Can you figure out a way? The other thing might be better to do this in groups and do heterogeneous groups. So in every group, there are some students who are good in math, some who are not good in math, but good in languages. Every group should have a leader, definitely. So that is what the suggestion would be. Do it for a shorter time and always ask the kids to reflect on it and give you some feedback, whether it worked, it didn't work, and how can we improve, and then go step by step from there. What was the second question, Ankesh? Ankesh, are you there?
Oh, I'm so sorry, ma'am. Yeah, I'm there. I'm just reading out the second part of the question. Also, please enlighten investigation with integration of other subjects.
So investigation, integration of other subjects, one of the best subjects to integrate is history. Where did this topic come from? So every last topic under the sun, every body of knowledge has come up because of a need. There was a need to solve Pythagoras theorem. There was a need to develop the entire number system. Our ancestors didn't have number system. They had maybe bartering, they drew images, then they had 1, 2, 3, many. Base 10 system came very late. So one of the best ways is to bring in history, that what was the need that which led to discovery or invention of this particular topic. The other is application into any industry. Who needs this topic? A simple question. Which professional will suffer if, let's say, there was no fraction? Or let's say there was no scientific notation? Or what will happen to the world if there were no numbers beyond 7? The smaller kids can be asked. What will happen to the world? Once I gave an essay to kids and I asked them to write, suppose you woke up tomorrow morning and there was no math. What will happen? So one is going into history. Why was this topic even invented? And the other is going into application. Who needs this topic? These are the two ways that it can be done. But there is also plain and simple, you can actually give an implementation. For example, how are graphs used by navigators? How is math used in geography in describing exactly how the map of the earth works? How is beauty connected with ratio? So ratio, and then there is an aspect of ratio called golden ratio. There is a saying that almost all beautiful objects in the world, they are there in a specific ratio. And then the kids go, but this one may become a little telling, like you're telling them there is a connection. Investigation could also be, is there a connection between beauty and ratio? Why don't you go and investigate and look up the most beautiful things using the internet and see what are the ratios of the various sides, and then come back with an answer. And quite possible, some kids may say yes, some kids may say no. Is there a connection between numbers and cooking? Go and investigate and get us some examples where numbers are really important. Get us some examples where numbers are not important. So these are some ideas that you can test out.
Thank you, ma'am. Ma'am, the next question is, ma'am, please suggest few techniques for 9th to 12th classes. How can we make teaching learning more effective at this level? And what about time management? Because lots of syllabus is there at this stage to cover up in a particular academic year.
Got it. So in 9 to 12, maybe you can reduce the amount of time you spend, but try these strategies. Convert a lesson a month into something different. Let's say you do one investigation, or you divide the class into 5 groups, give them 5 investigations to do, so that at the end of the class, they come up with something. Group work can be very easily done in 9 to 12. I personally tried it. Kids love it. They work with their own friends, or the teacher decides the groups, or the kids decide the group. And then anytime a drill work is needed, that is a huge exercise is given, the kids have to work it out together. It always helps to have part of the time in group. In fact, I would say test it out. 1 class a week, the kids work in groups to solve problems, normal problems. 1 class a month, where they do something different, something completely. Maybe it could be an investigation. If you attended the previous session, maybe they do something where art and math is connected. Maybe they play a game. 1 class a month, because the time factor is not so much because of syllabus. It's because of the motivation of the kids also. If the kids are less motivated, it's like you're going uphill. So you have to push against their motivation to get them to study. But if the kids who are coming are already motivated and energized, and they like you because you do something different in the class and you have a great relationship with the kids, then you will not have to work very hard to motivate them. So do less of something different, but definitely do. Start by using group work in the class. Syllabus actually runs very fast. As one of the teachers in a school in Jodhpur told me, the more creative I'm becoming, the faster my syllabus is running, because in his class, the kids would tell him, "Sir, we will do this exercise at home. In the class, please do the creative stuff." So he said, "Didi, my syllabus is running the more creative I've become." So that's a discovery he made. I would say test it out with these 2 things. Once a week, something different on a smaller scale, let's say group work to solve problems. Once a month, something different on a deeper scale, and see if that is making your classes more energized or not energized.
Thank you, ma'am. Ma'am, the next question is, how can we use methods of investigation with children with special needs?
So it's a myth to say that children with special needs are not creative. The entire aspect of special need was created because the kids were studying in huge classrooms with other kids, and a certain protection was needed, that these kids think differently. They think differently, yes, but doesn't mean that they are not creative. Test it out again. You might find they are actually better than others in solving investigations or doing creative work. And if anyone would like to comment right now on this, it will be great to hear from teachers who have tried these with kids, because sometimes they end up being better. But otherwise, if you have, I think it depends on situation to situation. If it's not working, or if it is disrupting the class even worse, end of the day, our objective is learning should happen. And if learning is getting interrupted because of using some kind of a creative strategy, it's a strategy that needs to change. Thanks.
Thank you, ma'am. Ma'am, there's one more question that please suggest some topics. Please suggest some ideas for topics like shapes, fraction for implementing investigation?
So I would recommend for any topic, I'm not taking too many topics today because there is ample material on the internet. I would recommend go to a website and Ankesh, if possible, please type it there, NRICH, Enrich. They have investigations on every topic under the sun. They also invite students to submit solutions. They also have articles. And you will find investigations, you will find a teacher guide, and you will find responses submitted by kids from different parts of the world. So you have the entire package there. And if you just type fraction, they will rustle up hundreds and hundreds of investigations. It's N for naughty, and then rich as in a rich guy. So Enrich, that's how it is.
Thank you, ma'am. That's just a minute. I know, okay. Ma'am, that's it. Those are the questions. Other questions are related to certificates and attendance.
Okay. Any comments, any thoughts, any feedback which you would like to give here? Any share anyone wants to do? Anybody who has tried investigations and has any tip, anything which you feel that, ma'am, you missed this out and you would like to add?
Ma'am, there's a comment response. Think of a possible solution, a real life problem, to create problems on your own. Any subject can be integrated with mathematics using a real life problems.
Yeah, that's a great suggestion. That give children like, okay, the answer is 13, form a question. And then the answer is, let's say 13, form a question anybody can do. You can even ask which functions should I differentiate to get 13 from, what should I add to get 13, or create a linear equation with answer 13. And then now form a question which has math and one more subject, but the answer is 13. You can keep making it more and more tricky. Yeah. Thank you, sir or ma'am, whoever gave this idea.
And there's also a response. Thank you so much for such an informative, interactive session. Kindly give us all the links, all possible links, which can make maths learning more fun and enjoyable in class.
Thank you so much. Just explore Enrich. Enrich has also got a lot of articles that you can read, and they have millions of investigations and questions, and it's free, and they don't expect you to sign in or anything. So it's quite a treasure trove of stuff for you to explore for the whole year. Okay. Thanks, Ankesh, for your support.
So yeah, there are floods of thank yous coming in and everybody is appreciating the webinar. A lot of informative session where information was shared in the webinar. So thank you, participants, for joining in. And that was all for today. We will be joining you, back for the next session on Maths Masterclass next Thursday, same time. The recording of these sessions would be shared post the webinar is over. We'll need another 1 day to share back the recording. The similar manner, you'll get a response on your mail ID, and the mail, to keep it simple, what we will do is we'll keep all the recording of the session 1, 2, and 3 simultaneously together in the same mail, so that you don't miss out on any. The same mail will also have a link to feedback. For audience who are joining us from Facebook channel, may not be able to share the response immediately, but the follow-up mail will have the feedback link. You can share your response. To the questions that are coming in for certificates, there would be certificate of attendance awarded at the end of the entire webinar series. The webinar series ends on 22nd of June. Till then, thank you for joining in. Thank you, ma'am, for the wonderful.
Thank you. Thanks, UP team, and thanks all the participants. Okay, bye.